Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, so welcome to my very early morning webcast. Hopefully in this webcast we will be tracking Comet Borisov. Ooh, we're getting some, looks like some issues there with some stray light. Let me go turn out some lights in my house here, see if that helps. The comet is extremely low over the horizon. This will be a very, very challenging object to try to image. But as we get closer to November, it'll get higher a little bit every morning until it peaks at about 41 degrees over the horizon at this time, or actually at 6 a.m. Eastern Time in November, before it starts to descend and becomes a southern hemisphere show. So stand by and enjoy. Hopefully we can get this comet today, but no guarantees. This is going to be a very challenging object. Alright, the lights are off, and yeah, this is interesting. So we've got quite a bit of stray light in the view. The auto guider is also having a little issue. So, normally I would be streaming from one laptop and taking the images from another like I did last time, but Windows updates decided now's a good time for updates. Again, massive update install. I told my other laptop to update and then shut down, but apparently it didn't actually complete the update process until I started it up again this morning. I should have anticipated that. Hey Microsoft, here's an idea. When I tell you to update and shut down a computer, I want you to completely finish the update process so I don't have to deal with it next time I start up the computer. Just a pro tip from a user here who is a little disappointed in your software. But fortunately, my secondary laptop working fine, so that's what I'm running the imager on tonight. The other laptop that I had planned to hook up to the CCD camera has just now finished its update process. Hooray. It's still useful to some extent. I can hopefully pull up the chat on this other laptop. Although I imagine this morning I'm not expecting a huge turnout just due to how early in the morning we are right now. Turn off auto contrast. Hopefully that does its thing. So, turning off the lights in the house. I don't know if that helped. And that's a bit interesting. It's a bit interesting that it didn't really seem to help a great deal. Reset the auto guider. I want to turn off automatic contrast adjustment so it stops overriding my settings where I want the image contrast, and then I have to restart the imaging. Oh, what are you doing? Why is it putting the star down there? That's weird. Okay, hold on. Abort. Reset the auto guider again. Give it a moment to settle down before I start the imaging. Now start the imaging. So, my plan here is that even if we don't see the comet in the live images, I'm going to do some fancy stacking and hopefully pull something out. The comet is moving relatively slowly against the background stars, roughly a pixel every minute or two, and I'm running 1-minute exposures. So it's fast enough that it's a problem if I'm running 10-minute exposures, not a problem if I'm running 60-second exposures. So direct tracking with Neo Tracker is not really worth it at this time. Direct tracking with Neo Tracker, due to the slow speed, would be rather jerky, actually. So my best bet is to actually just run the images while tracking on stars, and then stack the images based on where the comet's predicted to be astrometrically afterwards. And I may write some custom software to do that. Alright, as we get up out of the muck, hopefully that glare you see those diagonal lines running through the image, hopefully that reduces. It seems like it reduced just now quite a bit. I'm not sure what light source that was from, but as we get higher in the sky, hopefully that'll become less of an issue. I'm running 2x2 binned exposures, so you lose color data but gain some sensitivity that way. The comet, this interstellar comet we're looking at tracking tonight, is magnitude 17. It's extremely dim. Alright, I finally pulled up the chat. Hey everybody. And yes, David Schmidt, this is live. Seems like we got some Aussies in the chat. Hey guys, welcome. Yeah, and Windows should allow you to not do updates at all. The user does not update themselves like normal security. And the user does the update themselves like normal security procedures. Yeah, you would think so. I mean, it would be less disruptive to activities, wouldn't it? So, another challenge I'm facing this morning is that it seems like Sky Safari Pro has not included this particular comet in their list of comets. Let me check again this morning, see if that's changed. But when I checked it, I think yesterday, they hadn't updated their database to include this comet. Now, the comet's extremely dim, which is probably why they haven't included it. They don't normally include objects this dim, but given the unique circumstances here, I really think they ought to include it. Alright, let me do a manual update. Okay, so actually it hadn't updated the database since last week, so maybe if I'm lucky, they've included it now. Because I would like to be able to see where the comet ought to be relative to the background stars. That's tricky to do when it's not actually in the database of minor planets that this program includes. So let me search for it now. The comet's designation is C/2019 Q4 Q4. And the name is Borisov. Hey, they included it! Oh, excellent. I am so happy. Thank you, Sky Safari Pro. Thank you, thank you, thank you. You guys are awesome. Okay, now let's see. How do I adjust my field rotation on this thing again? Oh, it's under. Okay, it's. Whoa, no, it's not under that. It's field width, not field rotation. Oh dear. I hit the wrong button. And actually, it needs to be flipped vertically. This telescope inverts the images. I slewed to the expected coordinates of the comet from JPL, so hopefully it's in the field of view. I'll have a better idea of that in a minute once I get my bearings straight here. Scope display. Okay, they hit it under there. Alright, that's fine. So something like that. Maybe. Is that what I'm looking at? Oh. I'm upside down from where I thought I would be. Okay. Scope display. So it's actually more like that? Well, no wonder I'm dealing with a really dim guide star here. Okay. Yeah, that's where I'm looking. Okay, so the comet, I don't know if you guys can see my cursor. Let me know if in the chat if you can see my mouse cursor. If you can, the comet's supposed to be right about where the mouse cursor is, and I don't see anything there at the moment. That's not entirely unexpected, given the dim nature of this object. Oh, actually, okay, so I'm sitting pretty there with that. Okay. Show comets. Okay. So, we won't have a huge amount of time to try to image this comet tonight. Because twilight will be setting in less than an hour now, about 50 minutes from now. but I'm going to trust that I'm seeing things correctly here in terms of the stars I think I'm looking at are correct. Then I am pointed in the right location. Okay, I'm going to try to take slightly shorter exposures, speed up the guiding a bit, as that would help. But it's too dim. Okay, that's not gonna work. Oh well, I thought I could get away with it. I can't. I'll leave well enough alone on that then and just keep guiding at 1 second exposures. It's better when I have a much brighter guide start, but I haven't had time to really plan that out. If I had, I might have gone for a different direction. Oh, I definitely would have. Oh, I should have done that. 67 Cancer is positioned such that if I'd rotated the scope, the camera differently, I'd be looking at... Wait a minute. Oh. The camera's actually rotated right where it needs to be. Whoa, what happened there? Just random contrast issues, or... What the heck happened there? Oh, yeah, random contrast issues for the win. Okay, so actually, what I need to do is move the telescope up and to the left a bit. Okay. I was looking at the wrong orientation. That's no fun. The good news is that I think I can get a much, much brighter guide star in the field of view in pretty short order. Go that way, go that way, go that way, go that way. I think it's that way. Yeah, it's that way. Okay. Okay, I'm flying blind here a little bit. I do have a couple stars for reference of where I should put them. This star here needs to come down here. Sorry, and I missed the chat. I know I'm trying to handle a dozen things at once here, but are you guys able to see my cursor? Someone tag me in a comment. Let me know if you're able to see my cursor or not. Come this way. Come that way, come that way, come that way. Come on. A little more, a little more, a little more. Okay. Autoguider, take a picture, and please be in the field of view. Yes, 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 yes. Much, much better. Okay, I am so happy about that. So we've got a nice, big, bright guide star right in the autoguider. Just where Sky Safari told me it would be. This is why I love Sky Safari. Move it up a bit. The higher it is in the autoguider, the more favorable that will be to the positioning of the comet. So I'm going to move it up a little bit more. Up a little bit more. Okay. Right there, right there. Now, 0.01 second exposures. Oh yeah, I can do that all day long. About 0.05? Yeah, it's a little too dim. 0.08. Still a little too dim. 0.1015. That's better. That's nice and brightish. I'm going to call this Borisov B, just to separate the images a bit. Now we have really fast auto guiding to compensate for the effects of the atmosphere, make everything nice and sharp. Excellent. So you guys can see my cursor. Excellent. Thank you guys. Alright, so we are in business. So the comet's going to be low in the field of view, but in the field of view nevertheless. And moving up. Perfect. So I was a little wrong where I pointed you guys out before where the comet should be. Maybe if we're real lucky, we'll be able to see it now. I don't know. We shall see. It probably will have to take a new dark frame, though. That's unfortunate. I think this is the fastest I've ever operated the adaptive optics unit. Yeah. So it's taking a dark frame. So the comet is actually somewhere over here in this region. Might even be right there, if we're lucky. So we are dealing with a very dim object, as I said. According to Sky Safari Pro, its magnitude 17.8. Current distance 3.3 astronomical units. So the reason we know that this comet is interstellar, didn't come from around here, is the fact that it is very strongly hyperbolic. In fact, I believe it's even more hyperbolic than Oumuamua, the first interstellar object ever discovered just a couple years ago. And now, in just a couple years later, amazingly, we've discovered a second one. So, okay, it should be right. See these two little faint stars here? That one and that one. It should be just a bit above those, somewhere up here. But 1 minute exposures, even with 2x2 binning, may not be enough to see it in the individual raw images. It doesn't mean that it's not going to come out, though. If you remember my last webcast showing the winged star, we didn't really see the wings at all until I stacked the pictures. So if I stack enough 1 minute exposures and I align them based on the predicted coordinates of the comet, I'm hoping to pull the comet out and actually be able to see it, even if we don't see it in the individual images. So we're not looking at the top right anymore, we're looking over here, right around here somewhere. And yeah, the other interesting thing about Comet Borisov is that it was discovered by an amateur astronomer. And quite the remarkable discovery it was. But right now it can only be seen in the early morning hours just before sunrise like this, and very low over the horizon. Current altitude over the horizon from my location is 20 degrees. So that's not much to work with. I'm going to try something foolish here. We're going to stop the auto-guiding for a second, stop that for a second, and we're going to go for 1 5-minute exposure. I'm just going to designate that differently. Alright, resume the auto-guiding. And then start a 5-minute exposure at 2x2 binning, just to see if that pulls anything out of the muck. Now it should be moving rapidly enough that in 5 minutes it might be a little streaked. And the problem with that is if it's not bright enough to show up, then the fact that it's moving against the background stars that I'm tracking on means that it will never actually rise above the noise level of the individual images, or the individual pixels, I mean. So that's a potential issue. That's why I don't really want to run 5-minute exposures the whole time out here, because you may start to lose something from the motion of the comet itself. The apparent motion is almost entirely in declination, and it is 1,207 arc seconds per day. Oh well, actually the right ascension motion is 112 seconds of right ascension, which is actually more. That's about on par, a little more maybe in right ascension as well. So Forget what I said there. That's not quite accurate. Let's see. Let's just take declination for a moment. 1207 per day divided by 24 hours in a day divided by 60 minutes. Yeah, that's what I thought. About 0.08 arc seconds per minute. So it shouldn't quite move a pixel, especially in these 2x2 bend images. I could get away with 2-minute exposures and be just fine. 5 minutes, though, you're starting to push the threshold where even in these 2x2 bend images it may streak a bit and you may lose something. Plus, I still have some straight light or something there causing those diagonal lines in the image. They were definitely brighter earlier, but they're still there. But yeah, guys, how cool is that? I mean, an interstellar visitor discovered by an amateur astronomer. That says something about the power of amateur astronomy. Now, he was using a much larger telescope than what I'm using. He was using a telescope that is 0.65 meters. That's over 3 times the size of my telescope. And there are powerful telescopes that you can use on sites like itelescope.net, but it's tricky to be able to get down to these altitude limits where they're that low over the horizon. Of course, if you have your own telescope and you can set up your own observatory the way you want, you can position it with a dome that lets you get down to those kinds of altitudes. But if you're in a roll-off shed observatory, you may have a higher altitude limit on what the telescope can point at before it sets over the walls of your roll-off shed observatory. If you don't know what a roll-off shed observatory is, just picture a shed with a roof that's on rails that can actually be pushed off the shed. And inside the shed, you have your telescope. It's a very popular way to do an amateur observatory, but it has its drawbacks in terms of minimum altitude limits for most setups. Some guys, they'll design it so that the scope sits a bit above the walls, and you can get better shots that way. Alright, just 45 seconds left on this 5-minute exposure. Can I enlarge the screen? Yes, I can enlarge the screen. Embiggen. Okay. And what we're looking for is roughly in the middle of where I've got the screen positioned right now. Right around here somewhere. It will have to take a fresh dark frame exposure, which will take another 5 minutes. And time is precious this morning, so I probably, unless we see it right off the bat, I probably won't fool around with these 5-minute exposures past this point. I may go to 2 minutes, though, just because that's probably a better approximation of what my limit is on exposures in terms of length of the exposure. Yeah, it's way too bright. Okay, it should be right about there, right up here. It'll help once the dark frame is subtracted in 5 minutes. So we have about 30 minutes until astronomical twilight starts. The sky will begin to brighten, and within about 25 minutes of that, we will have basically lost any chance of seeing the comet. But again, Just because it doesn't show up in the individual exposures doesn't mean it won't show up if I stack the images aligned on the comet. Now that's very tricky to do when you can't see the comet. Most amateur astronomy software is designed so that when you stack the images, you align on something that you see in the images, whether it's the stars or the comet. If you can't see the comet in the individual exposures, you can't align on it in programs like Deep Sky Stacker. However, if I astrometrically solve these pictures and determine the coordinates of every pixel in the picture based on the positions of the stars, I could write my own software to possibly stack them, or at least align them. I suppose I could stack them too, but I don't really know how to do some of the more advanced stacking methods. But yeah, actually I could just have it average the frames. Averaging is easy. I can do that. So I may write my own program specifically for this comet because I've never had to deal with this level of difficulty before. I may write my own program to actually align and stack the images. So that'll be an interesting process. Obviously not something I'm going to be able to do right away, probably not even today. But later this week I will work on that program, especially if I need to, because we can't find the comet in the pictures, entirely likely, and deal with it that way. Just automatically align the pictures based on the coordinates of the image. So I'm going to use astrometry.net's software to astrometrically solve the pictures. I run that locally off my desktop computer, but you can also use it on the web and download a FITS file. The FITS file is the raw format the pictures are saved in, and have that data embedded. So the comet should be moving up and to the left in the images over time. So if we see a faint little streak or a faint little smudge, especially if it's in that direction, then we know we probably have it. But it's going to be tricky. It's going to be very tricky. The dark circle you see, you might notice there's a dark patch here. I don't know how well that's coming across in the stream, but that is just dust mote on the CCD. That'll be taken out in post-processing by subtracting flat field images. That's calibration used to compensate for dust or dirt on the CCD, any unevenness in the field. Okay. So I don't immediately see it. I'm not terribly surprised by that. I'm going to abort doing 5-minute exposures. We're going to go to 2 minutes. And we're going to run that for the rest of the time we have remaining. Good news is it seems like the stray light, whatever it was, has passed. It's no longer a factor. So that's good. So these will be nice, clean images. 2 minutes apiece. and we will just stack them and try to pull the comet out of the noise. The magnitude of the comet is 17.8, according to Sky Safari Pro, and that's pretty close to where JPL said it was. High 17s. And for those who don't know, the higher the number, the dimmer the object in the magnitude scale. Magnitude 7 is the limit of what you can see even with your averted vision under perfectly dark skies with no light pollution. Oh, and how could I forget? We have a waning gibbous moon out here tonight. So there's a nice bright moon shining in the sky, raising the light level. I do have pretty dark skies here at my house, if there wasn't a moon in the way. So on top of everything else, on top of the fact that it's, only 20-something degrees, currently 22 degrees above the horizon, we also have the moon to deal with, and its magnitude 17.8. Yeah, that's extraordinarily dim. If I manage to pull this off at all, it'll be a miracle. It will be by far the dimmest comet I've ever imaged. So I really would have been surprised a bit to see it in those 5-minute exposures. Just seeing it right away would be wonderful, but hopefully stacking it by aligning it on the stars and stacking it based on the coordinates will help. Okay, so it's got to take another dark frame exposure. And then we will have about 20 minutes until astronomical twilight starts. Let's see. And then nautical dawn, nautical twilight will begin at 6:24 a.m. Eastern Time. And at that point, it's basically going to be lights out. But that should give us somewhere between 10 and 20 images that are usable at the 2-minute exposure level. With the comet above 20 degrees, I mean, maybe, just maybe I can pull this off out of the stack. It'll be interesting. It's gonna be, like I said, the most challenging comet I've ever photographed. It'll get easier as we go day to day, so don't fear if we're not able to get it tonight. We will get it at some point. I will keep trying on this object until we do. A month from now, we will be where? Magnitude 15.7. That's closer in magnitude, to give some perspective, to the central star in the Ring Nebula. It's already right now way dimmer than the central star in the Ring Nebula, which is a very challenging star to see through your telescope. Okay, so these are the 2-minute exposures. Sorry, I'm adjusting the contrast here of the image, trying to get it to a comfortable level. And yeah, I don't really see it in the individual exposures. But hopefully, with some stacking, we can start to pull it out. Not going to be the kind of stacking you can just do in Deep Sky Stacker, though, that's for sure. If it works, though, actually, you know what I could do? Ooh, I could get fancy with it. Ooh, I like this idea. I just had an epiphany. I can take some of the code that I wrote for NeoTracker for tracking the comet with my telescope and just use that code for tracking the comet for the purposes of stacking. Because it will be able to calculate the coordinates of the comet. I just have to set it to calculate those coordinates for J2000 instead of equinox of date. The telescope wants the coordinates to be, my telescope wants the equatorial coordinates, the right ascension and declination, of the comet to be precessed to the equinox of date. In other words, coordinates that are consistent with the current level of precession. It's not going to, the computer in the telescope is not going to calculate for precession after startup. When it starts up, it calculates for precession of the stars in its database, the planets, the moon, all of that. But after that point, it leaves it up to the user. And so when you feed coordinates into the telescope, it wants you to calculate for precession for the telescope. So that's what I've written my NeoTracker to do with the LX200. I forget what I did with the ASCOM, though. I really should check on that. I'm not sure if ASCOM wants it in J2000. I would think ASCOM would want it in J2000. I need to make sure my code is sending it to ASCOM in J2000. That's something I haven't tested. I haven't really tested NeoTracker with ASCOM. But anyway, I could just take that code, which calculates the coordinates of the not the satellite. Man, that's a Freudian slip. The coordinates of the comet, and apply it to stacking the images. Say, okay, just calculate those coordinates for me, but instead of sending a command to the telescope, align the images on those coordinates. Once I get the astrometrically solved FITS files that have the WCS data embedded, I'm pretty sure PyFM, or maybe it's AstroPy, one of these Python libraries is very good at handling, I think it's AstroPy, is very good at handling FITS images, and can even handle WCS data, I'm pretty sure. So that should simplify that process. Is there a schedule? Yeah, unfortunately, the trouble with this is scheduling the next stream for doing this, for imaging, is not really possible. Because it's all dependent on the weather. And right now, this time of year, it's still in sort of a summer weather pattern where usually the mornings, this early in the morning, there's decent weather, but anytime in the evening at a reasonable hour, it's a crapshoot. It really is. And tonight was clear throughout. When I went to bed, it was clear, and when I woke up, it was clear. I think it's just been severe clear all night. But most of this past week has not been that way. This is really the first clear night in a while, basically since my last webcast. So it's just sort of random, and I have to play it by ear according to the weather. Also, I'd like to try to get this comet on a night where there's not a bright, waning gibbous moon shining light all over the place, and when the comet gets a bit higher. So all of those factors will play to my favor as we go on here in the coming weeks. It'll get easier to see this comet, and I'm pretty sure we will get to the point where it won't be too hard to get images of the comet live on a stream where you can actually just see it instead of having to do fancy stuff to stack the images and try to pull it out of the muck. So we'll see how that goes. But I have to play it by ear, so please do subscribe, please do ring the bell, and hopefully you'll get notifications. Also, I will try to post community tab updates. I didn't do one for this stream because I knew it was going to be kind of difficult to get the images, to see it in the live images. But next time I do this, I will try to post a community tab update to let people know the night before when I plan to do it. I kind of have to wait to the day before to see what the weather's going to do. Didn't know if it would be like 30 minutes later than tonight's. It'll probably be around the same time. I mean, yeah, as we get closer to December solstice, astronomical twilight will occur later and later, which will buy me some time. But I would probably still try to get going on these images around the same time, if possible. Now you will notice, I think, with every 2-minute image, the background, not the stars, but the background will get darker. And that's because as this comet rises higher, you're dealing with less sky glow. The lower it is on the horizon, the more sky glow you have to deal with. So that, again, as we get later into the year and this comet gets a little higher, it'll be easier for me to potentially see it, because you'll have less sky glow to deal with as well. Yeah, the community tab, if you go to my YouTube channel page, youtube.com/MEzierHunter, or if you just click my Astronomy Live icon, it should take you to my home page, and there's multiple tabs along the top there, home, videos, and then there's one that says community. So if you click community, you'll see community posts. It's a bit like Twitter for YouTube. I can post polls, I can post text, I can post pictures, that kind of thing. And I try to give some updates occasionally when I know I'm going to do a stream like this. So check there as well. Mark Poole, ANSN broadcast. Night Skies Network. I don't know who Mark is. Ooh! Oh, cool. That's a plane. Where'd it go? Where'd it go? I love it. Shoot. It could have been... Could have been 2 minutes ago when the image started, but a plane apparently flew through the view. So you've got a... I should have said UFO! I'd get way more clicks, wouldn't I? Oh, darn my ethics. You've got a navigation light probably over here, and then I'm guessing this is the other navigation light. You probably have wingtip lights or something like that, and then a strobe. You know how sometimes these planes will have strobes that go off. That strobe fired off right there at the top of the image, it looks like. And so it streaked through the view there. Very cool. Let me reduce the contrast on that so you can see how much brighter the strobe is compared to the lights. Now, unfortunately, I wasn't shooting 1x1 images, so there's no color data there. Otherwise, you'd probably see a red and a green light. Well, that was a happy coincidence. If I am able to pull it out of the stack, I may go for a maximum brightness stack instead of an average, because then I could retain the full streaks from this plane and have a more interesting shot, be more likely to get picked up by the media. See, if I had streaks from a plane in the image. A plane flies by Comet Borisov, an interstellar visitor, and isn't even aware that they did it. So, the comet will be easier for you guys to see in the southern hemisphere probably late this year, probably into next year, January, somewhere in that time frame, I would think, as it passes below the ecliptic, the plane of the ecliptic, and it goes south of our planet. yeah, you guys in the southern hemisphere, I think, will have a better time of it. But here in Florida, it won't be too bad, at least by December or November. Actually, after November, that's right. After November, it starts to drop a bit for me here in Florida. Even though the declination is, I think, decreasing at the moment, because I'm at a fairly southern latitude here in the States, in Florida, it's actually getting higher in the sky still for me night after night, and it will continue to do so until November. Oh wait, oh no, the altitude is increasing. Declination is decreasing, yeah, slowly. So, yeah, around November, by then, it should definitely be bright enough and high enough for me to see it without a huge amount of difficulty. So if I go to November, mid-November, it's magnitude 15.7, and at this time it would be 40 degrees high in the sky, way higher and easier to see. Right now, it is 26 degrees high in the sky. So, a couple magnitudes brighter and about 20 degrees higher. That would be a huge difference. Yeah, clickbait, have 1,000 watching next time. Yeah, come see a UFO. Oh man, can you imagine? Darn, if I was just more like some of these Planet X channels, I would have a ton of viewers. It's the Planet X system coming in. It's Planet X debris hitting the atmosphere. Oh man, there's 100 different ways you could try to spin that plane. But no, honestly, it's just a plane. That's the other thing. When it's this low on the horizon, your angle that you're looking through the atmosphere is a lot more shallow. So statistically speaking, you have a much higher likelihood of running into things like airplanes. If it's directly overhead, the plane's got to fly directly over your head for that to happen. But when you're looking at it over a shallow angle, you have a much higher likelihood of having planes fly through the field of view. And this is a very tight field of view. I've got the adaptive optics unit on there. This is at the full 2-meter focal length of the telescope. Of course, I'm binning it 2x2, but still. Actually, that's a good point. I should have zoomed out. That image was much larger than what we're looking at right now. We're zoomed in a bit, but never mind. Doesn't matter. Hopefully, we're able to pull this Comet out of the stack, and then I can post the stacked picture with the beautiful streaks from the airplane in there as well. See, that'll be something that probably no other amateur astronomer has from tonight. So, a little advantage there. But hey, that's how Astronomy Live goes. You never know what you're going to see. Things can show up with no warning. At least you guys got to see something interesting, right? Something unexpected. So at this point, the comet should be forming an almost equilateral triangle with these two stars right up there, thereabouts. How bright is that star? That's a question. Okay, that's 15.9. So for some perspective, this star right here is magnitude 15.9. This star here is magnitude 14.7. So that gives you some idea perhaps of the magnitudes of stars we're dealing with here. And I think this star is a star that is actually 16.75, pretty close to 17. pretty close. Is it this one up here? No. Is it? Oh wait, that's... Oh no, that's magnitude 11? Really? That looks dimmer. Maybe it's a variable. This is magnitude 13.5. You can see how bright that looks. And magnitude 14.4. These, look really bright, but they're actually extremely dim. Way dimmer than anything you could see by eye. And even this super bright one here is magnitude 11. So, all these stars are extremely dim. But we're trying to catch something here that's over magnitude 17, so very, very difficult to do. The adaptive optics unit's running at 15 hertz right now, making 15 corrections per second for tracking and atmospheric distortion, causing the star to wobble around a bit. So that's running well. So again, we're looking for something around in this region of the image. Would the comet be labeled if I ran it through astrometry? Great question, but the answer is no. Not automatically anyway. Astrometry.net has no way of knowing when the image was taken. It doesn't really look at the header file of the FITS images to see if there's a date attached to it. And so it labels the stars based on their J2000 coordinates, and it doesn't have any knowledge of when the picture was taken or what would be in the picture. There's certainly no database of minor planets or comets or asteroids or anything attached to that software. I run it locally on my own desktop, so I've seen the files that are loaded into it, and it's just I just use the TICO database for stars, yeah, I should be using UCOC or something else, one of these newer astronomical databases, or really the Gaia data releases are the best sources out there. Let's see if I reset the contrast a bit. I really don't see anything. I just hope it comes out with stacking. It might, but it's going to be very, very tricky. And I'm just not going to know. I'm probably not even going to know the answer to that question today. Compare my first image with this one. I will afterwards. One of the problems right now, I wish I'd been able to flip which computer's doing what. If this computer that's doing the imaging was the computer that was actually just doing the chat window and I could load it up, I would. I intended to use my other computer to hook up to the camera tonight, but Windows updates forced me to switch my plans. So I can't open any other windows while these pictures are being taken. If I do, I risk corrupting the data. It screws with the camera for some reason. There's some incompatibility between Windows 10 and this CCD soft program that seems to affect this camera. And in fact, I've got another camera just like it. I've got two of these cameras because I thought this camera was dying because it was getting these horizontal anomalies in the image, where it was anomalously bright and dark and sort of like these Venetian blind effects going horizontally through the image. And I thought it was the camera that was dying, so I replaced it with another one, and it was doing the same thing. And I realized it did it every time I opened up a window on Windows 10. If I brought a window to the forefront or I looked at the chat window or something, it actually screwed up the image. So I can't load any windows, I can't review the old pictures until I'm done. If I had flipped the order, the way I had it set up was this other computer over here was going to save the images to my Microsoft OneDrive, and then I could just load the images from my other laptop. So I wouldn't have to open, sorry about that, I wouldn't have to open any windows on the computer that's doing the CCD soft imaging. That would be the ideal solution. But I don't have it set up to do that right now, unfortunately. So I will compare them, I will try to compare them briefly here tonight after I'm done imaging. I could even try stacking them aligned on the stars, but I already know that's not likely to be that productive. I'll give it a shot, and if I see a faint streak or something, I mean, that's kind of what I was looking for with the 5-minute exposure, but I'm expecting that's not really going to happen. So we're now into astronomical twilight, so at some point these images are going to start getting brighter. It's just a question of the comet's getting higher in the sky, so that reduces sky glow, but it's also, I'm going to adjust the contrast here and leave it. I'm going to leave the contrast right there, so we'll see if the background gets brighter or darker in the next image. The comet's getting higher, but the sky's also getting lighter. And at some point, very shortly, the fact the sky is getting lighter is going to overtake the fact that the comet is getting higher. And the sky is going to start to brighten in the image. It's been darkening in the image for the last few. I didn't check the last one, but I did notice for a while there, the sky background was actually getting darker on every picture. But that trend is now going to start reversing. And at some point, I'm just going to have to call it and say, well, we're done imaging for the night because it's getting too bright out. I will then take flat field exposures to compensate for these dust motes and subtract them from the image. Oh shoot, I missed it. I was looking away right when the new exposure came in, so I didn't see if it got brighter or darker. It looks about the same to me. You guys probably saw it, but I missed it. But in any case, it's certainly not significantly brighter than it was, even if it did get a little brighter, so we'll keep imaging here for a bit. Probably another 20 minutes. I mean, that's about the limit of what we can do. In 20 minutes, we'll be hitting nautical twilight, and at that point, I'm sure all hope will be lost of trying to capture it in the individual images. William says, yesterday morning I saw the ISS after twilight, thought it was a plane at first. Oh, that's cool. Yeah, actually, that's one thing I didn't think about. This interstellar comet got all my attention. I'm pretty sure there are some ISS passes going on for me right now as well. But those will still be going on next week and the week after that. Well, I don't know about next week, but they'll be going on for a while, so it's not every day you get an interstellar comet coming through the neighborhood. I did have some plans to try to track space station this month, originally, before I heard this news, but I put those plans to the side for the moment. That's the beauty of having your own telescope. It's totally at your discretion what you do with it. Oh, you're near KSC? Oh, you're not too far from me then. Yeah. Well, and the ISS passes should be occurring for me too. I suppose might get one this morning. I'm not sure. Let's see. I can look it up on Sky Safari anyway. Okay, so today is Tuesday? Sure is. It only peaks at 3 degrees over the horizon at 7:20 a.m. for me. But this evening, tonight, it will peak at 71 degrees at 8:47 p.m. Unfortunately, I will not be able to track that one for one reason. Well, one of the reasons is because I'm doing this right now. I'm not going to have the energy to set up the telescope again and do some tracking tonight. That's just not happening. Sorry. Oh, man. And then tomorrow night's pass is only 42 degrees. Or actually, it's in the morning. It's at 5 a.m. The weather would probably be better. Well, actually, the weather's supposed to be clear, I think. According to Clear Sky Clock yesterday, it said the weather would be clear today as well. So it would be clear this evening. 42, 43 degrees. Coming out of the northwest, headed to the southeast. I don't know if... Oh, see, now that says not visible, so it looks like that pass is not illuminated by the sun. Yeah, that would be too early in the morning, wouldn't it? So that's not even useful. The only one that's actually useful is this evening's pass at 8:47. Well, darn. I guess I'll just have to forego that. Yeah, right here is about where the comet ought to be right now, and there is something there, but it might just be random noise. It's not bright enough for me to confidently say, that's it! That's the comet! We'll have to check it and see if, in the individual images, when you string them together, is there any motion? Yeah, but we'll make coffee and think about you if you do set up again. Yeah, that'd be nice, but no. Sorry, guys. Not... Once a day is enough for me with the telescope. I got up at 3 a.m. to do this morning, and I gotta go to work today, so I am not gonna have any energy by that time tonight. Coffee or not. Yeah, it's gonna be a nice one tonight, isn't it, William? I'll think about it while I'm asleep. There might still be something there. I don't know. That might be it. Maybe. We're just gonna pretend. We're gonna pretend that's it. We're gonna say that's the comet. Hey, it'd be good enough for most of these other channels on YouTube, right? Oh, no, I didn't want to do that. I accidentally sent my Sky Safari program over to ISS. That's not what I wanted. I still want to see where Borisov is. So, yeah, can you imagine trying to discover this comet? I mean, yeah, you need a mighty powerful telescope to do that. Because, I mean, looking at this right now, if I didn't know any better, I'd say, meh, there's nothing here. But that doesn't necessarily mean there isn't something there. And it doesn't even necessarily mean that I won't see something there when I stack these images based on the coordinates. But the key to doing all of that, of course, will be getting good calibration images, getting rid of these dust motes. How long does it take me to set up? About an hour and a half when I'm doing polar aligned observations like this. So the telescope's polar aligned, it's on an equatorial wedge, and it takes a little longer to do that than when I'm just doing a regular out-as align on 2 stars. So I had to align based on Polaris and with the North Celestial Pole. It's aligned parallel to Earth's axis of rotation, and I use the iterative method. It's a lot faster than trying to drift align. Yeah, I don't see anything there now. It might not have been anything. It's a lot faster than drift align, which is why I use it. But it depends on the North Celestial Pole, the Earth's axis of rotation, being where the telescope's internal computer expects it to be relative to the stars. And wouldn't you know it, it works. Also, it wouldn't really work on a flat Earth, just saying. So yeah, I'm polar aligned with the telescope, and that whole process takes me about an hour and a half from start to finish to set up the telescope, get the camera attached, and get the camera focused and just about ready to go on the webcast. So I got up at 3 a.m., started looking at the weather, started planning where I was going to put the telescope, because this thing is really low in the east, which is my most difficult direction to observe. But there is a gap in the trees, and I had to position the telescope to be able to shoot through that gap and see it. And so I was able to do that. Fortunately, it so happens that this comet is currently sitting about where Castor and Pollux were, especially Pollux, at about 3 a.m. So by positioning the setup location for the telescope where I could see Castor and Pollux clearly through the gap in the trees, that's where I put the telescope and was able to get these images. Yeah, that's what comet hunters do these days, just take lots of photos and compare, usually using a computer. Yeah, not just comets, asteroids too, that's right. And they go after, especially, my understanding is, the gold mine is going after low locations near twilight, especially morning twilight, like this, because you're getting to see things that are coming into season, and you're seeing things. Oh, you can see how the background got lighter there, significantly lighter there. That's astronomical twilight setting in. So yeah, we're gonna lose it here soon. So yeah, they shoot low over the horizon at twilight, where the main surveys won't necessarily be looking in as much detail or as thoroughly. The main all-sky surveys, like Pan-STARRS and the others, they survey tons and tons of the sky, and so it's really difficult to beat those surveys in trying to discover something like this, because magnitude 18 is entirely within the realm of discoverability for something like Pan-STARRS. But the reason it's not called Comet Pan-STARRS is because a diligent amateur astronomer was the first to find it by surveying low over the horizon just before dawn like this, and with a very powerful telescope, and pulling it out of the soup, basically. Very challenging to do. So hats off to Borisov. That was fantastic that he was able to do that. Yeah, you might be thinking of SETI there, talking about using volunteers to look at pics to try to find a moving spot. There might be a citizen science project to look for new asteroids or something in all-sky survey data. It's possible. I think I heard something along those lines at one point. Have I tried the iPolar system for alignment? No. Is that like a polar scope type deal? I mean, I can kind of gun sight Polaris along the wedge once I get the tripod and the wedge set up before I put the telescope on there, but usually I just eyeball it and that's good enough. Yeah, that's another bright one right there. Getting brighter and brighter. Yeah, polar scope might be a good way to go, except I'm not sure. I guess maybe they make something for an equatorial wedge for a Schmidt Cassegrain like this. I'm using an LX200 Classic and just the regular old fork mount. Oh, you guys got some fancy stuff. Polar alignment, I use a QHY Polemaster camera. Saves so much time. Interesting, interesting. That would be a good way to go. I'm assuming it basically does some sort of plate solving to determine if your mount's pointed at the pole correctly or not. I mean, the iterative method isn't too bad. I can do a very quick and dirty iterative align, and once I got the scope fired up, I'd say it maybe takes me 15 minutes, 10 to 15 minutes. It's certainly way faster than a drift align, but probably, I'm guessing, not as fast as iPolar or maybe the QHY camera. I'm not sure. It's a real-time view. But is it plate solving the real-time view to figure out, or does it just show you like on the screen where you need to put Polaris to make sure it's in alignment? It sounds interesting. I might look into that, but oh, ha ha. Yeah, way brighter now, aren't we? Yeah, this will be the last image, I think, and then try stacking them. Once Polemaster has the stars around Polaris, it just gives a dot to move over Polaris and you're done. So, I'm assuming you mean you move the mount to put Polaris on the dot? That would make sense. I'm not sure what putting the dot in the software on Polaris will do, unless the Polemaster is somehow moving your mount. Bright light, bright light. Yeah, that was actually just twilight setting in. The background light level increased, and I've got the contrast levels. Auto contrast is off, so the contrast levels are fixed, and so you see the actual increase in the light. Again, these are high bit depth FITS files for those who aren't familiar with that, who might be watching. It sounds like you'd be familiar with that, Pasta, but maybe you too, Trip and Fool. But basically, these images are not just 8-bit images like you would normally get off a normal consumer camera. They're 16-bit images, and so they have high bit depth. The dynamic range of the image is much wider than what the monitor can display. So you have to tell the program what portion of the histogram you want to see. So I'm only looking at a narrow range of the histogram right now, from values that are currently 1,190 to 1,611. Actually, you guys aren't seeing the histogram window. Doesn't matter, but you're only looking at a narrow portion of the brightness values, which is still a wider portion, actually, than what an 8-bit monitor can normally display. You know, brightness values from 0 to 255, something like that. And so again, yeah, twilight is setting in. So we're gonna stop taking pictures, stop guiding, abort, stop. Okay. So at this point, I will fire up Deep Sky Stacker, see if I can find anything moving in these images. My guess is probably no. But maybe if I align on the images based on the coordinates of the images, we'll get something later. Like I said, I'll have to write a whole program to do that. But it might be a useful program to have in the future as well for stacking images of comets where you don't want to have to like manually align it yourself or try to... Because with Deep Sky Stacker, for example, you have to manually click every single... on every single picture you've taken, you have to click on the comet in the picture to get it to align on that comet, which is a bit of a tedious task when you've got, 100 images. So this might be something useful to have in general. Okay, and these raw files are not... There's no color data here. So you rough align, then you rotate around the right ascension, and it finds the stars around player. Yeah, it basically, you're doing artificial star trails by moving the mount. Got it. It then calculates where Polaris needs to be and superposes a red dot to align on. Yeah, gotcha. That makes perfect sense. That makes perfect sense. I like that. I figured you could probably do something... I mean, you'd have to write the code yourself, but you could do that with just about any camera. On the telescope. But anyway. Oh, cool. So yeah, that was the nav light. Oh, that's so cool. Okay, I'm gonna let's see if I can do another window capture here. Hopefully it'll let me do Deep Sky Stacker. Here you go. Okay, so you guys can see the picture that had the plane that trailed through the picture. You can actually see another UFO. Actually, I saw a picture like this on Metabunk, where somebody was claiming it was a UFO, or posting somebody that was claiming that it was a UFO, or thought it was unusual. And basically, yeah, whatever. The guys on there are so good at these things. If I told them where I was located and showed them when the picture was taken, they could probably identify the exact flight number. I might actually do that. But yeah, you got the nav lights here, and then you've got the central strobe light over the main body of the plane. The fuselage is there in the middle, which makes not only a strobe but also something else that you might not expect. The strobe can reflect off the engines on the wings. So that's probably a reflection off the engine on the wings there. And then you've got the strobes out at the tips of the wings. So that's cool. Very handy example picture to have if something like that ever comes up again as a subject of controversy or mystery. Yeah, you can see how much it brightened in those last few images, so if I reduce the contrast a bit, some of these other images are really nice and dark due to the comet being higher and the sky being darker. But I really don't see any clear sign of anything moving in a consistent fashion like I would expect for the comet. Okay. I'm gonna go ahead and stack these pictures. 40 minutes of pictures, that's good. Alignment, automatic, lights. Do an average stack. Yeah. Go ahead, do that or don't do that. I don't know. Don't do that. Alright. So while it's doing that, I'm going to start preparing to take flat field calibration frames. Yeah, Flight Radar 24 is a great site. I've got something like that on my phone, one of those apps. I should have pulled that up to see what planes were out there. But I could review that later and maybe figure out which of the flights it was. If I do figure it out, I'll post it as a comment. Alright, I'll be right back. Alright, I see it stacked the images. Huh. Well, I don't really see any super clear signs of any faint streaks. I mean, for a moment it looks like something is there about where I would expect the comet to be, but it might be a background star that's just not on SkySafari's chart. I'll have to review some more and see if that is actually a background star. Well, probably the easiest thing to do. It's worth a shot, just in case. Just in case that actually is something not of the background. For the sake of you guys, I'm gonna go ahead and just do a quick online astrometric solve on that stacked image and see if anything comes up at those coordinates. I'm betting there is something there that's just a background star, but it's worth a look just to make sure that that's all that is. meantime, while it works on that, I'm going to start taking calibration frames. Flat field calibration. Let's see. I can go ahead and turn off the telescope tracking. Oh, there's a couple ways to do this. One is to point up in the sky near the morning twilight, hopefully get something that's reasonably close to a flatly illuminated image without any stars. Well, that's not even close to flatly illuminated. Okay. Let's try something else. Let's try my garage door. No. Nope. Try again. Pointing way out there. Maybe. Let's see what the astrometry shows. just going to do the quick and dirty thing. Compare this to Google Sky. Oh boy, somebody's been chasing the same comet, I see. They even labeled theirs C-2019 Q4. Earlier this morning, somebody else also uploaded a picture just minutes ago of the same coordinates, and so it brought it up as a related image on astrometry.net. I see the same star patterns. I don't see the comet clearly defined in their image either. It's like snooping on other people. I don't know that I like this. Is that one mine? No, that's somebody else's. Also, not recent. This one was yesterday. Somebody else, similar coordinates. Again, don't really see the comet that easily. Obviously, this comet's getting a lot of attention. Alright. Let's see if that little spot I thought I saw was a background star. I'm gonna load that up in Google Sky right now. I know you guys can't see it. If I find something, I'll show you, but I don't think. Oof. Gosh, they really degrade the quality when it gets converted to Google Sky. I hate that. Yeah, there's a background star there. Is that the one I was looking at? I can't even stinking tell. Ugh, I can't even tell what I'm looking at with the Google. When it converts it for Google Sky, it's just the quality goes to absolute heck. I mean, I'm just looking at noise in that picture. Okay, well. I mean, okay, so there is a background star there. But I'm not sure if I'm also seeing something else. Anyway, fool with that later. Got some flat frames here. Let's see what happens if I throw those in the mix. Let's make sure we can correctly compensate for the dust motes and such. Bring these in. These are going to be flat. So now it will stack and remove the dust like magic. While it's doing that, I'm going to start warming the camera back up. I was able to pull the humidity out of the camera. I know last webcast I had to run the camera warm because there was some humidity in the CCD chamber. Needed to be taken out by replacing the desiccant, which I did. Not a problem there. Yeah, you're just in time for the end of the stream. Sorry. Alright, well that took out the dust motes. That's good. So you could see the plane's still in the average stack there of the 10 frames, or what was it, 20 frames? I'm going to try solving the newly stacked version that has the flat field subtraction on it. See if anything comes up. Yeah, 6:40 a.m. in Florida, 6:45 now. I'm going to be having to tear down here in just a couple minutes and get cleaned up and ready for work. But I will be... So the deal here is that I expect, in order to pull the comet out of the noise of the image, I'm going to have to do a custom program to basically align the images based on where the comet should have been in the images. Just for fun, I'm going to take a new set of flat fields. Yep, the sky's a little brighter. Runs that. Download the Google Sky version. So, yeah, there might be something in these images in about the right place. Let me share the Google Sky window now. It's hard to say because when you export the astrometrically solved version to Google Sky, the Google Sky quality is terrible. It just compresses the heck out of it and degrades the quality. no work. It worked before. Okay. Last time I tried to do this, it worked. There we go. Apparently it doesn't like being full screen, but if I make it not full screen, then Google Sky lets me share. Okay, so let's see. Can you see my cursor? Yes, you can. Okay. Oh, wait. I made it full screen. I shouldn't have done that. I don't know if it likes being full screen. I don't think it does. So, if I fade to the background, here's the Google Sky background of this region, which looks like it's an SDSS image. Yeah, it's SDSS. It's not actually Palomar, so it's actually higher quality image SDSS. And SDSS goes out to much dimmer magnitudes, but if I fade between it, like even this guy right here, this star, and this star, they are visible in my image. They're grainy. Very, very grainy, but like you can see there, like there's a little bit of grain that's a little brighter and a little brighter than the background. Part of that is, I think, because of the degrading quality of Google Sky, how it degrades the quality of my image when I export it to that format, the KMZ file. But you can see this star right here. If I fade to my image, that star's just like a little speck on my image. Now, not every speck in my image is a star. Some of it is just random garbage. A lot of it is random garbage. But it's like if you know where the stars are ahead of time, you can tell which specks are not just random garbage. And so, yeah, the area where the comet should be, I believe, is right around here. So maybe, you know, maybe there's something there streaking through the area, but it's iffy. It's hard to say. Give me my mouse. All right. It's real iffy. It's going to require me to write that custom program and stack these images aligned on the comet to be sure if it's really there or not. So stand by, guys, and wait for that. We will do that as a later stream. I'll take the code from NeoTracker and convert it to something that can align these images on where the comet was expected to be in the image. So, yeah, that's basically all for now. You can see the wide-angle view. The stars all line up with the expected region. The real question is just whether or not I can pull it out of the muck by aligning on the expected version of the comet and stacking the images. Really, really tricky one. Really tricky. But we may have some success yet. Alright guys, that's going to do it for this live stream. Thanks for watching, folks. Clear skies.